Florida Building Code sets minimum energy efficiency requirements for buildings. These requirements include the allowance of lighting power densities, often abbreviated as LPD, for different building spaces. Specifically, for offices, the LPD is set at 1.1 watts per square foot. For corridors, the LPD is set at 0.5 watts per square foot. It is important to understand that these LPD represent the maximum amount of power that can be consumed by lighting systems in these specific spaces. The question of whether engineers adhere strictly to these LPD or interpret them with some flexibility is crucial for understanding code compliance and lighting design practices. Some engineers choose what is called exact compliance. This means they design lighting systems that meticulously adhere to the specified wattage per square foot. In the case of offices, they ensure the lighting consumes no more than 1.1 watts per square foot, and for corridors, no more than 0.5 watts per square foot. This approach provides a straightforward way to guarantee the building meets the minimum energy efficiency requirements stipulated by the Florida Building Code. By sticking to these numbers, there is no ambiguity regarding whether the design complies with the code. However, some engineers adopt a more liberal interpretation of the LPD. They treat the specified values as guidelines rather than absolute limits. This approach allows them to incorporate other factors into the lighting design process. These factors might include the specific needs of the space, the availability of natural light, and the implementation of energy-efficient lighting technologies. Firstly, the specific needs of the space might dictate a deviation from strict adherence to the LPD. For instance, a high-task environment within an office space might require higher illumination levels than a general office area. In such cases, an engineer might explore ways to compensate for the higher demand through advanced lighting controls or the use of highly efficient fixtures, ensuring the overall power consumption remains within acceptable limits, even if a specific area exceeds the 1.1 watts per square foot guideline. Secondly, the availability of natural light plays a significant role in determining the appropriate lighting design. If a space has ample access to daylight, an engineer might reduce the reliance on artificial lighting, thereby lowering the overall power consumption. Strategies like daylight harvesting, where sensors automatically dim or turn off artificial light when sufficient natural light is available, can be employed. In this case, the engineer might design the artificial lighting system to consume slightly more power per square foot than the LPD specifies, knowing that the overall energy consumption will be lower due to the contribution of natural light. Thirdly, the use of energy-efficient lighting technologies provides another avenue for flexible interpretation of the LPD. Modern lighting technologies, such as LED fixtures, offer significantly higher luminous efficacy, meaning they produce more light per watt of power consumed compared to older technologies like fluorescent or incandescent lighting. An engineer might choose to use more powerful LED fixtures to achieve desired illumination levels, even if it slightly exceeds the LPD, because the overall energy consumption is still lower than it would be with less efficient lighting. Consider the example of an office space. An engineer might analyze the tasks performed in the space, the amount of natural light available, and the types of lighting fixtures being considered. If the space requires high levels of illumination for detailed work, and there is limited natural light, the engineer might opt for energy-efficient LED fixtures that consume slightly more than 1.1 watts per square foot. However, by using these efficient fixtures and implementing lighting controls, the overall energy consumption of the lighting system might still be lower than it would be with less efficient fixtures that adhere strictly to the LPD. In this scenario, the engineer is taking a liberal interpretation of the LPD but still achieving the overall goal of energy efficiency. It is important to remember that regardless of whether an engineer chooses exact compliance or a more liberal interpretation, the Florida Building Code mandates that the specified LPD are minimum requirements. Engineers are never permitted to design lighting systems that consume more power than the specified LPD. The flexibility lies in finding ways to meet the lighting needs of the space while remaining at or below the maximum power allowance. The interpretation of the code requirements must be done responsibly and ethically. An engineer must have a sound justification for any deviation from strict adherence to the LPD. This justification should be based on a thorough analysis of the space, the lighting needs, and the available technologies. The engineer should also be able to demonstrate that the proposed lighting system meets or exceeds the energy efficiency goals of the Florida Building Code. The code includes specific procedures for calculating the lighting power allowance, which can be used to demonstrate compliance with the LPD. These procedures take into account various factors, such as the type of space the lighting controls and the efficiency of the lighting fixtures. To ensure compliance, engineers often use lighting design software to model the lighting system and calculate its power consumption. This software can help them optimize the lighting design and identify potential areas for improvement. Additionally, engineers may consult with energy consultants or code officials to ensure their designs meet the requirements of the Florida Building Code. The Florida Building Code references other standards and guidelines related to lighting design and energy efficiency. These include standards published by organizations such as the Illuminating Engineering Society, often abbreviated as IES, and the American National Standards Institute, often abbreviated as ANSI. These standards provide detailed recommendations for lighting levels, lighting quality, and energy efficiency. In conclusion, the Florida Building Code's LPD requirements provide a framework for energy-efficient lighting design. While some engineers choose to comply with the LPD exactly, others take a more flexible approach, considering factors such as the specific needs of the space, the availability of natural light, and the use of energy-efficient lighting technologies. The key is to ensure that the lighting system meets the energy efficiency goals of the code while also providing adequate illumination for the space. Always remember that exceeding the LPD is a violation of the code. When considering ways to achieve the design goal, firstly, look at the space and its function to accurately calculate the lighting needs. Secondly, review all the latest in energy-efficient lighting options, including LED and smart lighting. Thirdly, remember lighting control systems can make a difference. Finally, make sure you use the right tools to verify the design is compliant.